any instruction given by any software. Excuse me. So the so any instruction given by any software will actually go through the. Am I recording? Yes, I am. All right. So all those instructions will actually go through the operating system. So the operating system is going to manage that and make sure that there is a communication between the users and the different application and the hardware, um, and the computer can actually be controlled, all operation, how the applications are operating on the computer and everything. So the operating system is there to make sure that it controls all the processes. Okay, so we'll take it from where we left yesterday. I think we were still talking about Linux as an operating system. So can you guys see my screen?
Yes, we can.
Okay, you can. I'm just trying to get the slideshow on, but it's not. Okay, I guess I will have to zoom it from here. Hopefully you can match. Okay. Give me a second. I'm just trying to make sure I'm presenting this page because it's not. Yeah. So we spoke about of Linux as an operating system. So a few things that what do you remember about Linux? Anything that you guys will remember about Linux specifically? Okay.
Everything.
Something wrong with this. Okay. It's not please. Okay, guys, I'm trying to do it a different way because the slideshow is not giving me the option. I hope you guys can see from this view here. I hope you guys can still see my screen, right? So, okay, we introduced Linux. There's a few features of Linux that we spoke about. The multi-user, multitasking. Linux was free, and the last thing that we spoke about was the Linux file directory structure. And we mentioned that in Linux will look at everything um, as files. So Linux looks at everything like files. just like how you go to a certain file, with the concept of Linux, everything is treated just like a file. Okay, not just document or images, but everything, the hardware, devices, and everything. So this is how it's going to work. For example, you have your /dev, which is the device file directory. So looking at that, you see that you have, for example, after when you have the functions when you have a file can be you have functions such as to open the file. You can open a file, you can close a file, you can write a file, and you can read the file. So this is how Linux will work. So after logging into the system, you can enter a command, okay, and that command will actually output a certain display to show which directory or which command you can use in terms of what you want to do. For example, if in the command you put /bin, in this case, what you are invoking is a short, the bin is a short for binary. So this directory will store the frequently used command. Okay, so so the frequently used command will be stored in /bin, and then you can have maybe /boot. This is a directory for bootloads file. What does it mean? It means this is a directory that will store some core files used for booting the Linux operating system. So this will include some links and images that are relating to booting of the system, right? And then you have the /dev, which is a device file directory. So the /dev is short for device. Okay, so this directory stores all the devices connected to the system. Okay, so it's going to store the methods of accessing all the devices on Linux. Okay, the same way that you access a file. And then you're going to have a /etc. This is a configuration file directory. So it basically stores all the configuration files and all the directories required for system management. Okay, so anything that you want to do with managing the system they are stored in this. And then you have the lib, which store some basics library of the system. Okay, so almost all application will need to use certain libraries, the shared libraries. So that's where in this directory, this is where they're gonna be. All right. So and then you have as well the media. You have the opt. Okay, the opt, which is just storing like additional softwares. Okay, which are installed on the OS. Yeah? For example, if you install, let's say you install a database, let's say an Oracle database on your computer, you can save the installation package in this directory, which is the opt. That's where the installation package is going to be stored. Okay, so by default, this directory will be empty. It's only when you want to store the installation package of any software that you want to install. Okay, so just note that Linux file directory is Linux as a type of file, and then we have all these file directories. Okay. If I think I forgot this, the media, this one is just to store all the removable information about the removable media. Okay, so this is automatically used. For example, if you put a USB, yeah. So this will be used. All right. So moving forward, we will introduce. So we have Linux, and then now we have OpenELA. So OpenELA is just an open source as well operating system. which was basically developed to strengthen the computation around the Huawei Coupang processors. So this operating system was just created to try and innovate, to promote innovation in cloud computing, big data, and AI. Right. So it's an operating system that is basically developed to really promote the innovation of cloud computing, big data, and AI. All right. So talking about the background of OpenELA, you need to note that the OpenELA operating system, ELA OS, is just a server that is operating a server operating system, which is based on the Linux kernel. Okay. So you need to note that it is based on the Linux kernel. What is this? Okay. All right. So your your ELA OS will be a server operating system based on Linux kernel. You need to know that this operating system is actually going to support multiple architectures, multiple hardware architectures, which can include the x86, the ARM, and this operating system is basically designed for enterprise level scenarios such as data management. You have your big data processing, you have your cloud computing, and artificial intelligence applications. So those are the type of scenarios that this system is built for. Okay, so it has certain key strength, all right, which we can mention, for example, the security. So LROS is really trusted, and it's really suitable for critical workloads. It's really secure and it's really stable, right? The stability. So it has been proven that LROS has a strong reliability. Um, Especially when it's integrated with Huawei's enterprise products. Okay, and we can also talk about the efficiency in terms of the performance for servers and all the data center environments. That's where we can actually see how LROS has proven itself. So the LR OS, right, is really integrated into the Huawei ecosystem. So over the years, LROS became like integrated with your Huawei softwares and hardwares, which makes it the foundation for many of these technologies. So it really plays a crucial role in all the Huawei servers, storage systems, cloud infrastructures like the Huawei Cloud. It use the ELA OS, the Coupang processors optimization, right? So that's how you need to understand the ELA OS from, I think, Huawei open source ELA. If we have to really see where it really came from, it was actually completed in 2019. Right, right. So this was a system that serves as an open source version of. There was a system that's serve as a version of an open source version of ELA OS, which we call OpenELA. All right. So in to develop the Coupang ecosystem and builds prosperity of the computing industry in China and around the world, the open source version of ELA OS was officially released as OpenELA at the end of 2019. So you need to note what is the difference between OpenELA and Ella OS. So OpenElla is just a open source version of Ella OS. All right, which was created to to foster global collaboration and drive innovation. So then Huawei decided to create the open source Ella OS, right, which we call OpenElla. Right, in 2019. So this platform is really serve as a community-driven platform for developers and enterprises. It's basically a foundation to how can I say that, to develop new computing ecosystems in China and worldwide. Okay, so the main purpose and or I can say vision of OpenElla when OpenElla was launched, the main purpose was to aim to like build an open and collaborative open source community, obviously, and also to kind of promote diversity in computing architectures. Why? Because it's supporting different architectures such as the x86, RRM, and other architectures. Okay, so it's really strengthened the Kupeng ecosystem and promote independent innovation in the computing industry, and it's also encourage global participation in building um, open source infrastructure. All right, so just to kind of summarize on that, you need to understand what is or open Ella. So basically, Ella OS is an operating system which is commercial, and it's run on Linux kernel, right? And when we talk about Open Ella, it's an open source version of Ella OS. Okay, so and then so which means the kernel base that they are both using is the Linux. In terms of architecture, Ella OS will support x86 and ARM, and OpenElla will also support x86, ARM, and other architecture as well. In terms of the focus, so you will have your Ella OS, which will be focused on creating databases, cloud computing, AI. All right, so we focus more on big data, cloud computing, and AI. And Ella, obviously, OpenElla, the same thing, but it's open more for innovation and different ecosystem development because it's open to the public now. All right, so there is a relationship between OpenElla and there is a relationship between OpenElla and other mainstream operating systems, right? So the when we look at this, so we have, for example, here you have Red Hat, which they're all using the Linux kernel. So we have, for example, Red Hat here, which is the commercial edition. We have a commercial edition, which is Fedora and RHEL, and then we have a free edition, which is SenseOS. Okay, SenseOS. So the relationship between OpenElla and mainstream operating system, as we've said, OpenElla is basically a Linux-based open source operating system, which means that it shares a common foundation with a lot of these operating systems. While also it also incorporates a unique innovation for its performance. Remember, we also spoke about the security. All right, and we also say it's really work better with the development in an environment of the Huawei Kupeng and Ascent processors. All right, so all those chips that you see to accelerate your AI processors, work better on this operating system. So when we look at OpenElla and Linux, for example, so obviously OpenElla is derived from Linux kernel, just like other operating systems such as Ubuntu, which is also on a Linux server. You have CentOS, which is also on the Linux era server, Linux kernel. You have your Red Hat. So that's the relationship between OpenELA and the mainstream. It's the Linux kernel. They are all derived from the Linux kernel. So they all inherit Linux stability. Remember, we said Linux were really stable. The security multi-user feature. Remember what we say with Linux? There is an option for multi-user feature. Okay, so which will really make OpenELA compatible with Linux softwares and development tools because of this relationship. So developers that are familiar with Linux can easily work on OpenELA because it supports the same shell command. So the same command that you use, the same shell command, file system, and package management mechanism that you use. So in short, we can say that OpenELA is just a Linux distribution that has been customized by Huawei for enterprise level, right? All right. So, and then if we have to compare OpenELA to other operating systems, such as Windows, what we can say is Windows is a closed operating system, is a closed source. So we have the graphic user interface, which is the operating system is based on the graphical user interface. So that's just a few things that can be in common between OpenELA and NAT. Um, while OpenELA is an open source and it is driven, uh, Windows will focus more on desktop and personal computing, but OpenELA is mainly used for servers, cloud platforms, data centers, and artificial intelligence applications. So OpenELA will actually provide a higher control over system scalability, resource management, and Windows. Okay, so in short, OpenELA and Windows serve different purposes. So Windows is for end users, OpenELA is for enterprises, servers, and cloud systems. So, guys, that is something very, very important to note. Um, so this is very important for you to understand that uh, we can have a few things in common um, between these operating systems. All right. So when we look at the relationships between OpenELA and different mainstream, so we can see that there is a few things in common, but not always serving the same purpose. All right. Let's let's do an introduction to the file systems on OpenELA. All right. So the system, the main function of this. So a file system method or a data structure used by an operating system to identify a file on a storage device or a certain partition of that hard drive in order to really organize this data. So in an operating system, a software structure that manage and store file data is referred to as file management system. So basically, the file management system is any software structure that will manage and store file data. So now, when we think about it in OpenELA, so the file system in OpenELA will just serve, how can I say, it's going to serve as the core component, which will be responsible for organizing, managing, and protecting the data stored on devices, such as your hard drive, your SSDs, or any other device that can be used as a storage. Right. So you need to understand the file system on OpenELA will act as an interface between operating system and the application and the storage hardware. So this will help the users and different programs to store, retrieve data from different sources. Okay, so that's the main functions of, if we can say, the functions of file systems in OpenELA. So it's basically you have a user-friendly interface which will help you in terms of disk management software. You have a disk management software, and then you have underlying hardware here, such as your hard drive. So this is the user. So the user going to be using this file system. So the file system can have file system APIs, certain software stack for object control and management, and you have your object and properties. So basically, the main functions of the file system will be to just make sure there is kind of an organization, right? So it will manage how your storage space is divided. And allocated to files. It will determine how files are structured on storage devices. So you have certain file operations such as what's that? You can create a file, read, write, modify, delete files. So so this file system will provide the system calls that application use to interact with stored data. So that is a few functions that we can actually mention here. All right, so there is a few file system that are actually supported by uh, by OpenELA. So we have like the which one is that? EXT4. So the EXT4 will actually be the default or most commonly used because it's stable and reliable. So this is just a file system. Okay, so you have as well your XFS, which is you have a high performance with that. So this is usually used for large files. Okay, so you have many of this. Okay, so you have many of these file systems um, that will actually play different role. Okay, so the file system, whenever you have an ext, so you have the ext4, which is the default and commonly used, but you also have ext3 to ext. So when we talk about an ext, what we talk about is a file system that is specially designed for Linux. Okay, and the most stable is the ext4. All right, and then you have your XFS V5. So this is on Linux. You have the FAT16, 32. So these are file management. So on Windows, you usually use the 16 and the 32. You will see, for example, if you want to format, for example, you want to format your USB, it suggests to you in what file system you want to format them, in 16 or 32. So those are just file systems. All right, so in summary, what we can say is that in OpenELA, the file system is just the foundation of all the data management. So the file system will just ensure that every file is stored efficiently. We can access them in a secure way, and every file is protected against being corrupted or being lost. So the file system will really play a crucial role in maintaining the stability, the performance, and security of your files. So that's why OpenELA is a strong choice for enterprises and cloud computing environment because of the stability of the system, operating system, the performance, and the security. All right. So those are the reason why these systems are really chosen by different enterprises. So it's very, very, very important for you to note the reason why these operating systems are used. You can't just take and build an important system on Windows. No, Windows is really, really weak. You know, even Mac OS is stronger than Windows. Windows, you always hear like viruses, and that's how the system is not secure. So the OpenELA kernel is basically derived from uh, from a Linux kernel, okay, which supports a wide range of systems, and each system is designed for a specific performance, a specific reliability, and compatibility as well. So the Linux kernel will support over 10, right? Over 10 type of file systems, which we've mentioned here. All right. So the default file system, as I've mentioned, will be the ext4, which is the fourth extended file system. So the ext4 is chosen for its stability, the compatibility, and its excellent performance, both with small files and large files. Okay, so in summary, OpenELA inherits broad file system support from Linux kernel. The default file system is ext4, which will offer us a balanced, reliable, compatible system. Okay, so depending on the application scenario that you're working on, so such as what you call this cloud computing, big data, AI, then you can select a specialized file system like the XFS, the BTRFS, that will depend on what you are working on. All right. So what is like, and then we have Linux. We always say the term GUI, which is the what is the GUI, guys? I'm sure there is developers in this class. There's people who develop apps or softwares or people doing IT. What is this when we talk about the GUI? Obviously, it's written on the screen already. So the GUI is the graphical user interface. What is it? Can anybody tell us?
It's the combination of elements on screen that you use to manipulate or interact with the computer.
Yeah, but can you tell us in simple words? In simple words, like when I ask you, what is the someone ask you, someone who's not from the IT world, and ask you what is a GUI?
Maybe effective tool.
Sorry.
Okay, you can continue.
Maybe it's an effective tool.
No. Try again.
Maybe it's an effective tool.
No, it's not really. That's too broad. Anybody else want to give it a try?
Can I come?
Yes, you can.
All right. I will just come. So the GUI. I think so. I don't know if you're connected with two devices. They give the feedback, so people who are listening are not able to hear what you're saying because it gives feedback from your end.
Oh, there's a feedback. No, it's surely because when you're talking and then the sound goes to the speaker and then goes back to the mic. So if there is any small delay in terms of the internet speed, it's going to give us that feedback.
Okay. So GUI in simple terms, I think it's that physical interactive part that interacts, or that the user is able to interact with the system through that physical element. Thank you.
Yeah, yeah, yeah. It's make more sense. So basically, when we talk about the GUI, which is the graphical user interface, so this is what we can present as um, it's a system just to present all the element as graphical components, such as your such as icons, windows, buttons. So when we talk about the when you are using a certain app, the GUI of that app is everything on that app, like the buttons. Because if you click on a button, it does a certain thing. You don't have to writing some command of code and write a full code to print something, but you are clicking on buttons, and behind those buttons are now activating code. So when we talk about the GUI of any application, is the buttons, the forms where you have to fill up. So this like how it looks, the external part of any software. All right. So the GUI will present all elements as graphical components, such as your icon, windows, buttons, the menus. Um, okay. So with the GUI, if you are on the phone, your main input device is your fingers. But if you are, let's say, on the computer, we have the mouse, which is the primary input device, right? So now, when we talking about a GUI in Linux, right? So in Linux, users can interact with the system in two ways. They can either interact through a graphical user interface, which is the GUI, or they can use command line interfaces, CLI. So command line interfaces is when someone writes a certain command for the computer to do something. You don't have to click on buttons, but you keep writing commands. So some people like to do that. You are using a computer, you keep writing code, and the computer is doing certain action instead of you having to click on buttons. All right, so that's the difference between a GUI and a CLI. So the CLI is the command line interface. So this is so in Linux you have the two options, the two ways you have the using the GUI or using the CLI. So both of these methods will serve the same purpose, which is to control, to manage the system, but there's a difference in interaction style, okay, and user experience. Because if someone is not really experienced, a beginner, they will rather use the graphical user interface because it's user friendly, it's suitable for beginners. But the CLI, you really need to know what type of command you are typing there. Okay, so when we have the GUI, it's gonna make it easier for to perform common operation like managing the files, the folders, changing settings, browsing the internet, uh, using other applications. You understand? So when you look at that, you can see all your uh, operating systems comes with that, right? But when it comes to the command line, the CLI is text based. So your primary input tool. So if you have the GUI, your primary input tool is a keyboard. Now with the command line, what will be your input tool? Your primary input tool? Anyone? Anyone tell us what will be your main input tool if you are using CLI?
So the commented to what?
I'm saying if we are using the GUI, the main input device will be our mouse. Now, if you are using the CLI, what will be the main input tool that we're going to use?
Keyboard.
Yes.
It's a command keyboard.
Yes. So the keyboard will be the main. So just understand that if you are using the CLI, the keyboard is the main because you keep typing and everything. But the GUI, you have your mouse. So that's how easy it is. So a lot of system administrators, developers, or advanced users prefer to use command line. So with command line, they can just write something like, for example, you write if it's, let's say, for example, you want to open a certain folder. You go on your what we call a bash. So you write maybe cd, the name of the name of the file. So I can have something like let me see if this is going to allow me to write there. Okay. It's not allowing me to write. Okay, so let's say I want to access a file. So if I write, for example, a comment cd, and then I write the path to the file, maybe it's in home, and then slash, and then this is the file name. No, not file name, name. For cd, you go inside a certain folder. So this helped me access the folder. So this command line open a folder, right? And then if I say ls, ls is to list everything. So if I say ls, same thing, home, and then folder, the same folder. So if I put these two commands, the cd is going to open the folder, but the ls is going to give me a list of all the files inside the folder. Can you see? So now, by using this command line, you need to really know what command line you are using. You understand? That's why it's for advanced users. Because if I'm using the GUI, I'm just going to click on a button that open the folder. I'm going to click on a button that where I can see the files. You understand? So that's the main difference. So the environment that we use for the CLI, the command line, we have your bash and your shell. All right, so those are environment where you will actually go and type all this. All right, guys, that will be all for this session. For those who can turn on the camera, please do that so we can take an attendance screenshot.